You're listening to the Common Descent Podcast.
Good day, William.
Hello, David.
How's it going?
Pretty good. Pretty good here down in Florida.
And good day to all of the listeners out there.
Indeed. Welcome back, everybody.
Welcome back. This is Common Descent Podcast, Episode 3,
Tres.
which seems like we're legitimate at this point.
I mean, it's the 3 times is a trend.
That's it. As long as this one goes out, I think that we're on the path to greatness.
I'm excited for it.
Next stop, fame.
It's feeling real.
And it's a lot of fun. I hope that everyone out there is having fun too. We've already gotten some cool feedback from people out there in the world. So
Yeah, no, it's been nice getting to actually hear from people who are hearing it.
yeah. So let's jump right in this time. I'm very excited for this episode. Last episode, our topic was all about crocodilians,
Indeed.
their diversity and their evolution, their fossil record, because crocodilians are Will's favorites.
Because
there
the
were
best animal.
some there was some claims last time that were made about maybe that crocodilians, were someone, I won't name names, someone said that crocodilians are the best.
I mean,
animals out
it's a solid claim to make.
We'll see. In an hour and a half, we'll see. We'll let the people decide. Today, I'm responding in turn with an episode all about my favorite animals, and those are snakes.
Yeah.
Just the coolest, in my humble opinion.
They are pretty cool.
Yeah. But before we get to that, we can jump right in and go to the news. So, this last couple weeks in paleo news has had some interesting stuff.
Mm-hmm.
So, Will, why don't you go ahead and start us off today?
Can do. All right, well, I'm going to start with the older of my 2 news items, fossil-wise. My first one is about a fossil reptile that has kind of the first solid evidence of live birth within the group Archosauromorpha.
Ooh.
And this is, it's a cool one. So they found a fossil in South China. It's about 240 million years old, looks like, but from a reptile called the Dinocephalosaurus.
Mm-hmm.
And this was an aquatic reptile, long neck, longer than its actual body length after the neck.
Cool.
So it was more neck than anything else in its length. And was definitely an aquatic one that they've known of before, and we talked about this last time with the aquatic crocs, that it's often been thought that these highly aquatic reptiles may have given live birth, and there's been evidence before and one other aquatic reptile found to do it, but this is the first one that's definitely in Archosauromorpha and has the solid evidence of live birth, which is cool because it lends strength to the idea that others may have been doing it.
Right. So Archosauromorphs being the group that includes crocodilians, dinosaurs and pterosaurs, and of course birds.
Absolutely. And that was one thing they pointed out, was the fact that both modern representations, the birds and the crocodilians, have shelled eggs.
Right.
And if this is the case that their ancestors or previous older members of the group had surpassed eggs to live birth, or had foregone eggs more accurately, it's an interesting thing that, comment on, the possibilities of that lineage.
Yeah, I guess it's been a weird thing for a long time that just about every major group of vertebrate life has evolved live birth at some point. Lizards and snakes, sharks, mammals obviously have done it, but the Archosauromorph group, for some reason, we've never found good evidence of live birth in this major group of animals before.
Mm-hmm. This one, the actual evidence for this one is it's a fossil of a grown animal with the skeleton of a juvenile inside it, curled in the fetal position. And the reason they think it's not food is that the face it is facing forward in the body, and this animal's been known to eat its prey head first, so if it were food, it should be facing toward the back.
Mm-hmm.
And the evidence for the fact that it's live is there's no evidence of any shell around it inside the skeleton. There is one other animal that, one other reptile that has been shown to give live birth. That was the maybe other one called Corystodera, which is another group of reptiles, but the placement is unsure whether they are in Archosauromorpha or Lepidosaurs, which would be with lizards and snakes.
Right.
And so this one may be the first archosaur that has solid evidence for live birth, or the second if the other one gets placed in.
Right.
But either way, there's exciting evidence.
Interesting.
So the one other thing I looked up about it was because we mentioned mosasaurs last time giving live birth, and so I was curious what evidence there was around that. And evidently the main evidence for mosasaurs giving live birth is the fact that very young juveniles of mosasaurs have been found in open ocean water fossil deposits.
Okay. As opposed to up on the shore, like sea turtles go up on shore to lay eggs.
Exactly. So it's the idea being, if they are getting out into the open ocean that young, it's most likely that they were born there and did not hatch and then swim like heck out into the open waters.
Interesting.
Cool. So yeah, it's interesting stuff. It's cool that there were reptiles giving live birth even a ways back.
Yeah, and in a variety of different
Groups.
Evolutionary families. Yeah.
Mm-hmm. All right, that's it for me.
Very cool. So my first news item today is about the same age, I believe. We're going maybe a little older. This is a synapsid from the Permian of South Africa. And it may be the earliest evidence of a venomous vertebrate in the fossil record.
Well, that's cool.
So synapsids are the groups of the synapsids are the major group of animals that today the only living members are the mammals. But way back in the day, especially prior to the dinosaurs and such rose to dominance, synapsids were represented by all sorts of cool different forms. One of those forms was this, kind of small dog-looking animal called Euchambersia. Like I said, South Africa about 260 million years ago. And for a long time, people have suspected that this animal might be venomous. And they suspected that because of these odd features of the skull. And so this new study that came out isn't suggesting this for the first time. This was suggested like 70 or 80 years ago. But this new study takes a very close CT scanning, the high-tech approach to trying to confirm this. And what they found was confirmation of three main characters. So venomous animals have to have, but when we look at modern venomous animals like snakes especially, there are venomous mammals today. The platypus has that little venomous hind spur on its leg.
Yeah.
Which is ridiculous. Venomous animals have to have a place to store venom, a way to get venom to the part where they're delivering it to the opponent or the prey or whatever, and a way to inflict a wound to get the venom inside the body.
Yes.
This animal has possible evidence for all three. So on the maxilla, which is the upper jawbone, there's this bowl-shaped depression, which is what you tend to see when there's a gland sitting somewhere. And it doesn't, people have sort of shot down suggestions of it being a salivary gland or a salt gland, like some animals have. It connects directly to the maxillary canal, which is a little tube that runs down the jaw and exits on the teeth. And the teeth, and this was, I think, the first thing that really clued people into this hypothesis, the teeth have these cool ridges running down them.
Oh.
And ridged teeth are something you see a lot in venomous animals because it channels the venom down. And it's important to note that any one of those three features wouldn't really be enough. Lots of non-venomous animals have ridged teeth. Lots of animals have cool glands in their jaws. Most, if not all, vertebrates have that maxillary canal. But the fact that they're all present and it doesn't seem to be explained necessarily by other suggestions makes it quite likely that this animal may have been venomous. that it had a venom gland in its upper jaw. The venom traveled through that canal and then channeled down the teeth when it bit stuff.
Very cool.
Yeah. And it's similar, modern snakes, a lot of venomous snakes have the almost tube-like teeth. And the venom is delivered almost like a hypodermic needle.
Mm-hmm.
This guy didn't quite have that.
Yeah.
It would have been more like the Heloderma, the Gila monster, which had the venom kind of pours out into the mouth a little bit and runs down those ridges into the probably prey.
Mm-hmm.
In this case, venom is most often for prey as opposed to protection. Is a nice benefit of having venom if you're really strong, like rattlesnakes and such.
Yes, exactly.
So this is a cool example of, first of all, a unique setup for venom.
Mm-hmm.
Because modern venomous animals don't have the venom gland in that particular spot on the upper jaw.
Yeah, because I was about to say with Heloderma, it's in the bottom jaw.
Yep.
Even though it's similar teeth and similar design on the grooves, but it's flipped.
And in snakes, it's way back in the head.
Mm-hmm.
But it also means that there was this possibly surprising diversity to the early ancestors and cousins of mammals.
Yeah.
That even, venom had evolved back then in this group, as well as all these cool different shapes and forms of these animals.
Venom is cool and I'm sure we'll get into it later on in the conversation concerning what we're talking about. But it's cool that so many animals have found venom as the solution to survival.
Yeah.
Because it's a good answer. It's always incredible to me how early on it came up.
Yes.
Like, that's cool. That an animal nearly 300 million years ago already had a fairly sophisticated version of a venomous bite. Like, gland, grooved tooth, and large enough tooth. Like, that's cool.
It's interesting because I saw a bunch of news reports that were talking about it, saying, the earliest venomous animal, which is odd, which is one of the reasons you have to be careful about hyperbolizing too much. Mm-hmm. And I saw someone in a comment section on one of these things say that, where they basically said, no way this is the earliest venomous animal, because insects and gastropods and arachnids were around for a long time before this. And almost certainly they had, I don't know of any direct evidence, but as a general rule, invertebrates did it first.
Yeah, on most things that animals do nowadays, they were the first ones that did it.
Yeah. So early venom system, potentially, in a cool fossil creature. Very
cool. All right, well, my next one also talks a bit about teeth, is one major part of this study that this news reported on. This is a news report about a new setup for the evolutionary tree of horses that shows a trend in horse speciation, or as new species show up in fossil horses, or showed up in fossil horses, that actually goes against a common thought on how evolution works or tends to work. And so, for the background, typically the way it's thought to work when animals speciate, when animals suddenly give rise to multiple species from a few or single species.
Right, a short-term radiation.
Exactly. When there's a sudden burst of new species of that animal, it has always been seen and thought that there went along with it a increase in diversity of morphology, meaning that you saw a lot of new body shapes come up.
Okay, new traits that have adapted, and that's what's allowing you to diversify.
Exactly, and so that's what they call adaptive radiation, when either new ecosystems open up, or the animals' numbers increase, so they're pushed into new ecosystems, or whatever happens. And the classic example is Darwin's finches, where you have a single species of finch or a couple species of finch that ended up on the island, that then spread to the different environments of those islands and got a series of different beaks to handle different foods.
Right.
That's always been the common, working model for how, when sudden, quick, and vast speciation happens, it's usually driven by adaptation to different environments or foods or body types. Horses didn't do that.
Weird.
So they went through the 7 living species and 131 extinct species of horse, and did phylogenetic studies on them and placed them into a evolutionary tree and marked the time periods and places of mass speciation. I think they said there was 4 major moments of just huge, suddenly there was a whole bunch of new horse species.
Right.
And during those times, the things they looked at was tooth morphology and body size. And the reason they looked at those is because for the basic background of horses started out fairly small, little forest-dwelling guys, about the size of a house dog. Just not very big. And they had teeth that were much more like a deer's for eating soft leaves. They had multiple toes. They were forest-dwelling little cute scurrying animals. And then as some of them began to spread out from the forest into open plains, you needed a bigger body because there's bigger predators out on the plains. And you need to be able to see farther and handle those. And you need flatter, taller teeth for chewing on grass, which has silica in it and lots of wind-blown dust, which would grind down your teeth.
Yeah.
And we see this with lots of animals that are plains living animals. This is a very common trend between forest dwelling and plain and grazing animals. But when they looked at the teeth during the speciation, they didn't see any more variety, like any increase in percentage of variety compared to periods of non-speciation or of low speciation.
So they were evolving a bunch of new species without necessarily evolving a bunch of new traits.
Exactly. And in fact, they actually saw lower morphology diversification during a certain of those periods. So
interesting.
What that suggested to the researchers was that it could have just meant that the environment was so rich they could speciate without major competition. They were just able to spread out and become different, but still all be doing basically the same thing.
Cool.
Which, yeah, and it's a big deal because if this is the case here, that could make us rethink other, animals' evolutionary histories that we've looked at before, because, it may be the case that you don't have to have a whole bunch of niche partitioning, of specializing to different environments to have that speciation, or horses are weird. It was basically the 2 things that the article said is the potential that this is showing.
That's cool because it really, it shows us that really anytime we think it's like, all right, well, this is how this process happens. Eventually you get actually, sometimes it happens this way too.
Yeah.
And that there's more diversity in how evolutionary processes proceed. It's really cool that it's horses, because horses are a classic and iconic evolutionary case sample. Because there's a really good fossil record of them. They've been really diverse. So it's fun to see that group of life revealing this unexpected trend to us.
Yeah.
And wouldn't it be delightful if the wonderful case study animals that we use for a lot of evolutionary studies turn out to be weird?
Yes. It's and I love these moments because, like I said, the 2 things it brings up is either something we've been assuming is not as all-encompassing as we thought, or is, at times in the past flat out wrong. We've had more. Or you find out that there's just key scenarios where something completely different can happen, and it's cool when it's with something well-known that, horses were mundane's not the right word, but they were a solid, go-to example. You could just always call them out. Everyone generally knew what you were talking about. Now that's not the case.
That's cool.
It's all changed, and that's really exciting to see what horses were doing.
Yeah, it's fun to note that we're always learning new things about evolutionary processes.
Yeah, even the things we thought we knew really, really well.
Yeah.
And that's cool.
Indeed. Speaking of evolution of cool traits, my next news piece, the last news piece for this episode, is an unusual one for 2 reasons. First, because it's about plants, And I think this might be the first time we've talked about plants on
Gross.
the podcast. Yeah, plants. Yeah, like we said, we're a bit biased towards vertebrate animals.
They don't even have muscles.
The other reason it's an unusual one is because there are no fossils involved in this news story. This is
Oh, cool.
pure genomic evolution.
Interesting.
So this is a study about carnivorous plants. So one of the most preposterous things in the world that is also a real thing is the fact that there are a bunch of plants out there that lure, trap, and digest insects
Yes.
and eat them. Because evolution's never satisfied with
Yeah.
what it already has.
Yeah. It's my favorite group of plants.
Yeah, the best group of plants, I think. The plants that are most like snakes and crocodilians.
Yes, exactly. That saw what the cool people were doing. It's like, well, yeah.
Yes. So this study looked at specifically Australian pitcher plants. They did a whole genome sequence of Australian pitcher plants to determine what genes were building what proteins that made up the digestive juices, basically, that these plants are using to digest their food.
Oh, cool.
And they compared it with a handful of other carnivorous plants. Turns out carnivorous plants have evolved multiple times in multiple different groups of plants. The Australian pitcher plants are part of the overall family that includes things like starfruit,
Mm-hmm.
whereas the Asian pitcher plants, as well as sundews, are closer related to cacti and carnations and beets and more.
Really?
And the North American trumpet pitchers are part of the family that includes azaleas, blueberries, and things like that. So at least a handful of times, this strategy of getting protein by digesting animals has shown up independently in plants.
That's like because I knew about there's the sundew which sticks its prey. There's the famous Venus flytrap and pitcher plants. Did
Yep.
not know pitcher plants were so far spread on the family tree.
Yep. They are polyphyletic, which
That's
is to say they don't all share the same ancestor.
mm-hmm.
Yep.
That's pretty crazy because they're
It is.
so similar looking.
Yeah. Now that is not the news, incidentally. That's been known. That convergent evolution of the same trait showing up multiple times. What they found is that the proteins the plants use to digest their food are also convergently evolved, and they're evolved. So the proteins the enzymes that break down the food are very closely related to proteins that plants have for defense against disease.
Oh.
So plants commonly produce enzymes that for example, specifically break down chitin, which is a major component of the cells of fungi, which are common plant parasites.
Makes sense.
Well, conveniently, in natural terms, chitin is also what insects use to build their exoskeletons.
Sure is.
Yep. So what it looks like has happened is these pitcher plants exapted, right, co-opted these defensive proteins to produce them as a digestive fluid for when they capture insects. And very similar proteins were co-opted in very similar ways in at least 3 different groups of carnivorous plants.
Very cool.
So down to the molecular level, this convergence has acted on very similar process using very similar original material to end up with a very similar end result.
Mm-hmm. That's cool.
Yeah. And it's a really neat example of how evolution often works. We talked about venom before.
Mm-hmm.
There have been studies on snake venom that do the same thing, right? Looking at what proteins they're using and the relationships between the proteins. And it turns out that a lot of snake venom proteins are just modified digestive proteins.
Yeah.
Like pancreatic enzymes and things like that. And a lot of the time, instead of evolving something completely new, most of evolution seems to be taking something you already had and slightly changing it.
Yeah.
turning it on, producing it in your mouth instead of in your stomach or your pancreas, and then modifying it from there until you have this cool cocktail of venom or plant digestion, whatever
Yeah.
it is. And that happens multiple times.
Well, and that's one of my favorite aspects of evolution is the fact that it's much like when you have a job to do but you don't have the right tools, and so you have to rig a tool or
Yes.
MacGyver something to you need to unscrew something, you don't have a screwdriver or a wrench, so you have to find something around the house. And evolution does that in the body of animals constantly, to where it's like, all right, I need something to do this job. Got an elbow bone I'm not really using right now. Might be able to turn it into and just repurposes something that was either not being used heavily or was open for more use. And then eventually down the line you get to where now it's a feature of that group.
Yeah.
And then could get repurposed later on when it speciate again.
Yeah,
And
for
it's
something else.
constant.
I love your MacGyver analogy. That's actually really cool. The only thing I would amend, for the sake of the listener, is instead of it being like MacGyver, I need to do this thing, so what can I use?
Yes.
It's more like, hey, I happen to have this in my hand when it turned out to be useful for this job.
Yes.
But instead of going out and buying a better tool, I'm just going to keep changing this as it works to do the job that I need a tool to do.
Yes.
And then at the end of it, you get this thing, and someone's like, how did you use that to build a house? Like, oh, it used to be a hammer.
Yeah.
And I added all this stuff to it as it became useful to saw through wood and, find studs and things like that.
And when those things compound is when you get those weird animals like armadillos and
Yes.
odd things that have body structures that are really weird. And I love it, especially in because when that original switch started, it's not like a plant just suddenly started eating insects. At some point that protein got switched over for something more minute for likely a completely different purpose.
Oh, yeah.
And then, step by step, started eating stuff.
Yep. That's there will be a whole episode, I'm sure, about this process called exaptation,
Yes.
where a trait evolved for one purpose and then later was co-opted. Small dinosaurs that evolved feathery coverings for controlling their body temperature or for display, and long arms for capturing prey, and small light bodies for running around the environment. Hey, look, now you have all the traits you need. If you jump off that tree, maybe you'll discover a new selective process.
Yes.
Which is cool.
It's really interesting.
Fascinating processes. Speaking of fascinating processes, I think it's time to move on from news.
I do believe so.
And to our discussion. So, yeah. Back to the main desk. Topic says. All right. Today's episode topic is the best animals that have ever lived.
Is the argument being made?
Like I said, at the end of this episode, we'll have a Twitter poll.
Absolutely, we will.
And you can tell us which one of us is dead wrong.
Yeah, you can decide who you want to be the favorite fans of.
Yes, I like it. All right, so let's talk about snakes. Snakes are very cool animals. Don't really need much of an introduction. They are very famous.
They
People
really
know
are.
what snakes look like. We're very familiar with them. Most people already have opinions made up about these animals. But to start talking about them, and starting with the modern snakes, I want to just address what snakes are. And what snakes are is really weird lizards.
Yes.
Snakes belong to the group of life called squamates, which is all the various lizard families plus snakes, and they all evolved from ancient lizard ancestors. The first squamates were lizards.
Yes.
So snakes are just a very strangely evolved, very specifically evolved group within this lizard family that has become so weird and so diverse that, we think about them separately. But they are at their heart lizards. The thing that's famous about snakes, of course, is their body shape. Long, slender bodies, short neck, short tail, and then a long body in between.
Yes.
With no legs. That's kind of the classic, this is what snakes are famous for. Which is interesting because, first of all, not all snakes have no legs. Boas, pythons, and blind snakes actually have little bones left over back where the body vertebrae transition to the tail, where the hip would be. A lot of those snakes have little remnant bones of hip bones or leg bones.
Yeah.
And in boas and pythons, in many species, they actually stick out of the body in these little tiny claws. They're called spurs.
The pelvic spurs.
Pelvic spurs. And some species, at least, the males will scrape them on each other as they're having what must just be riveting battles for dominance. Like watching two guys just wrestle on a mat. So snakes aren't complete, most of them are completely no vestige even left of the limbs. But some of them still have it. And they're not the only lizards to evolve that way.
Yeah.
Limblessness and a long snake-like body have actually evolved many times in lizards. There are lots of skinks that have snake-like bodies. There are the largely limbless pygopod geckos, the glass lizards, the worm lizards. This has happened many times. It's a popular body plan.
Yeah, which, we talked about that last time about, popular body plans. This is a super interesting one because it is not one you would reach logically if you were just asked, to design, because completely getting rid of your legs is a very extreme and seems like it would limit you.
Yes, and that leads into my reasoning for why snakes are my favorite animals of all time. And that is, snakes belong to a group of life called tetrapods.
Yes.
The first tetrapods were the fish that crawled up onto land with their primitive limbs. Tetrapods means 4 feet.
Yes.
And since that evolution has progressed, tetrapods have used their limbs to do all sorts of cool stuff. Running, jumping, climbing trees, swimming, flying, digging. And you would think that if you took this all-important, iconic piece of your anatomy and evolved away from it, you would limit yourself.
Yeah.
And in most cases, that does seem to be what happens. Most legless animals tend to be very restricted in what their habits are, what their lifestyle is. Even their diversity is often not, there's only a handful of them. They only live in a certain range. Snakes are completely different from that. Snakes got rid of their limbs and have expanded to be one of the most diverse clades of life in the modern world.
Yeah.
There are somewhere around 3,500 species of snakes in many different family groups, evolutionary groups. And with their limbless bodies, there are very fast snakes that move swiftly over the ground, burrowing snakes, snakes that spend their whole life swimming in the ocean, snakes that jump across the sand, snakes that climb trees, and, the best ones, in Asia there are snakes that jump out of trees, flatten their bodies like squiggly frisbees, and glide through the air.
Yeah. Yeah.
So this group of animals has evolved to be able to do many of the locomotion habits, many of the habitats that their limbed relatives, distant relatives, do with their legs. But snakes are doing it with just a tube of a body. They live on every continent not called Antarctica, from as far south as Australia and New Zealand all the way up to Scandinavia in northern Europe. And they have all sorts of cool diversity. You have most snakes Most of the snakes you think about in your backyard belong to the colubrids or close relatives of that family.
Mm-hmm.
So, if you think of your standard backyard snake,
Yeah.
garter snakes, water snakes, rat snakes, milk snakes, pine snakes, king snakes,
Yeah.
those are colubrids. In the tropics, the thick-bodied pythons and boas are very common down there. You've got your tiny little blind snakes, your scolecophidians, which spend a lot of their time digging around
And
underground.
they're so weird.
They are super weird. There are two major groups of venomous snakes.
Mm-hmm.
The vipers, which include rattlesnakes, copperheads, cottonmouths.
The ones we're familiar with.
The ones that are really popular over here in North America. And the elapids, which are cobras, mambas, coral snakes, and sea snakes.
Yeah.
The exact relationships between these groups are questioned back and forth, but those are really the big main groups, and then there's a bunch of other families as well. Snake diversity there's also a lot of diversity in size.
Yeah.
The smallest snakes are literally worm-sized, a few inches long. The largest snakes, the longest snake in the world is the reticulated python. The largest and heaviest snake in the world is the green anaconda. And these get to around 20 feet.
Yeah.
Anaconda a little less, reticulated python a little more, as far as documented records go.
Yes.
There are stories of, crazy long snakes, but as far as has been confirmed, around 20 feet is as big as they get, which is plenty big.
Yeah. I mean, that's same length as the largest crocodile that's ever been successfully caught.
Yes. It's also the length of a great white shark.
Yes. I mean, so it's big.
They're huge. One of the weirdest things to me about the movie Anaconda
Mm-hmm.
is that in the movie their snake is supposedly like 30 feet long,
Mm-hmm.
which is weird to me because it's like they were saying 20 feet wasn't enough.
Yeah.
Which is I would think that a 20-foot anaconda is sufficiently intimidating to be your main villain.
Yeah. It's they just need that 50% more.
The
50% more scary.
So snakes are super diverse, but again, that body shape is not unique to them. The main thing that is unique to snakes is their skull morphology. So snakes, a lot of animals have joints throughout their skull.
Mm-hmm.
So if you look at us, right, we have one joint. It's
Yeah.
at our jaw, where the jaw hinge. Many lizards have different joints throughout the skull that make it a little more flexible. Snake skulls have gone way off the rails with this trend.
Yeah.
They have joints all over the skull. This is part of what allows them to eat big prey,
Mm-hmm.
bigger than their heads. You'll hear people often say that snakes dislocate their jaw, which isn't really what they're doing. But the jaw joint is all the way in the back of the head, and the two sides of the lower jaw, where they meet at the chin, aren't fused together.
Yeah.
So they can actually separate side to side. The upper jaw can do this too. So the snake jaw can just open up in all directions.
Yeah, it opens up down like ours, but also sideways.
Yes. And so they can stretch it and bend it around the prey that they want, which is a very unique thing to snakes. Snakes also, there's a few other traits that separate them from most lizards. They don't have external ears.
Mm-hmm.
They don't have eyelids. Their organs are weird.
Yeah.
Because of their long bodies. So, for example, paired organs like kidneys or lungs or sex organs, testes and ovaries, instead of being side by side, they're one in front of the other.
Yeah.
Which is cool. Snake lungs, incidentally, only one of the lungs works usually.
Yeah, the other one's just like a little pea.
Yeah, it's a little non-functional sac that kind of hangs out behind the working lung.
Which is another super weird thing of not only have you gotten rid of your legs to get this long, adaptable body, you got rid of one of your lungs because you got a long, versatile body.
Yeah, they've done a handful of weird sort of evolutionary follow-ups to evolving their strange body plan and lifestyle. Some snakes also have in addition to venom, right? Not all snakes are venomous, but venom is actually quite widespread throughout snakes.
Mm-hmm.
But many snakes are just venomous enough to, hinder a tiny food item. Only a small portion of snakes are venomous enough to be used for protection.
Yes.
The vipers, the elapids, the attract aspids, which are the ones that have their fangs pointing sideways.
Yes,
That,
like the
I guess
stiletto.
they swing their heads.
Yeah,
Yeah.
those are crazy.
Yep. The other sort of famous thing I just want to touch on is that in some pythons and boas, and in some vipers, they have those heat sensing pits,
Mm-hmm.
which is only shown up in a couple different groups of snakes. And they're basically an extra set of sensory organs on the face that sense heat. Now, there was a time that I thought that they were picking up the infrared light like our eyes do, which it turns out is not what they do. They are actually, it seems, sensing heat as opposed to the radiation, like the light itself. They're not photoreceptors.
Yes.
But in other ways, they do have things in common with the eyes. So they connect to a similar nerve pathway as vision does. So they kind of, sort of do have heat vision.
Yeah.
That they can use to track down their prey. So snakes are all sorts of diverse, all over the world. But they all have that same general body shape, that long, slender body with the weird organs and the short neck and short tail. The one thing amidst all this diversity that always struck me as really interesting, that is common among all snakes, is their diet.
Mm-hmm.
All snakes are predators.
Yes.
And as far as we can tell, this has always been the case. They eat a variety of different prey items, from insects all the way up to large mammals. There are egg-eating snakes, but there are no snakes that are omnivorous or herbivorous, which is interesting because even most of the most famously carnivorous groups of life have had omnivorous or herbivorous offshoots.
Yes. And it's also worthy to mention that true, pure carnivorous diet is unusual.
Yes.
That we call those hypercarnivores. And most things that you call carnivores take some plant or vegetation in their diet. One, it's easier.
Yeah.
That's the case with bears, which are often seen as predators, but eat just as much and often more plants than their meat because you can find it more times.
Yeah,
and
they
even
have the teeth for it.
Yeah, and even like mentioned last time, crocodilians, past fossil crocodilians, there have been true herbivores, but in modern ones, in recent years, it's actually been observed that they likely do eat nuts and fruits occasionally, not often, but occasionally, to just supplement their diet. So it's really odd for an animal. There's really only a few animals. Cats are mostly hypercarnivore, polar bear, snakes, but it's also that all snakes are hypercarnivores, which is weird.
And they don't even seem, as far as I know, they don't even scavenge much, if at all.
I mean, I think the closest they come is when human-cared snakes are fed a dead mouse. But otherwise, I've not heard about any wild evidence.
No. They are almost completely strictly predators. And what's interesting is it's possible this is a restriction of their specialized jaw morphology.
Yes.
It could very well be that the same anatomy that allowed them to become so special and so unique and so diverse also doesn't lend itself to evolving along different dietary pathways.
Which is
so they may have evolved themselves into a corner in a sense.
Yeah.
With their skulls.
What has allowed them to eat basically any animal they want, from insects to deer.
Yes.
Has also limited them to only eating animals.
Yes.
Which is a weird interesting trade-off.
Yeah. So that's snakes today.
Yes.
Now let's jump into their history. So last episode, we did crocodilians. We sort of worked our way backwards up the family tree. This episode, we're going to do the opposite. We're going to start right at the origins.
With the old ones.
And work our way forward. So for starters, a note on snake origins and where they came from. The earliest snakes, the earliest fossil snakes actually come from the Jurassic period. So back around 150, 160 million years ago, right about the middle of the age of dinosaurs. But by then, they're already a bit diverse.
Yeah.
Which indicates that they first evolved sometime well before that.
That we just may not have fossils for.
Yes, that we just haven't found them. And that's a big thing with snakes, is that their fossil record is not very good, especially early on. We have a handful, but for the most part, they're hard to find. And they're weird. Their features are strange, which makes it hard to compare them to other animals directly.
Yeah.
And at the same time, their features aren't strange in the cases of their general body shape, which means that the snake fossil record is also full of other ancient lizards that evolved similar body shapes.
Yes.
That aren't necessarily related to snakes.
Brings us back to the issue between convergent and ancestral evolution.
Yep. So trying to find the earliest snakes in the fossil record is a lot like... It's like if you took all your cousins and all your aunts and uncles and your second cousins and you got all together in one big extended family picture, and then 5 generations from now your great-great-granddaughter is asked to find you in the picture among all your relatives.
Yes.
The fossil record at this time is full of things that are ancestral snakes, close to snakes, and not very much like snakes at all, but very much related to snakes at all, but deceptively similar to them.
Yeah.
So both the genetic component and the fossil component are awkward when it comes to the very early origins of snakes. We know generally where they fit within the lizard family tree. They belong to or close to the corner of lizards that are called the anguimorphs.
Oh.
Which is the corner of lizards that includes all the best lizards. They include the monitor lizards, such as the Komodo dragon and all of its relatives. It includes the Gila monsters we mentioned before, the beaded lizards as well in North American deserts. The anguids are a cool group of armored lizards, which include the glass lizards and the alligator lizards.
Right.
And the anguimorph part of the lizard family tree also includes the mosasaurs.
Indeed.
Who are the coolest snake cousins. So for people listening, if you don't know what a mosasaur is off the top of your head, even if you didn't see Jurassic World, if you saw the trailer for Jurassic World, there's the scene where they're hanging the shark over the water, and that giant sea monster comes up and snaps it out of the air. That's a mosasaur.
Yes. A particularly overly big mosasaur, but yes.
This was a group of lizards that had evolved to large, whale-like marine forms. So they were lizards that were convergent with whales.
Yes.
Which is just about the coolest set of words that I can think of for evolutionary history.
Well, and I love it because they are another marine reptile that has got to large predator status, like the marine crocs last time.
Yep.
But with different... They had slightly different answers. Like they have a long flattened tail like a sea snake. They have fully 4 paddles for limbs. Yep. Which is really cool that they... like how purely aquatic they were.
Yes, we'll have to do an episode about mosasaurs as well.
Yeah, absolutely.
Yeah. So these are sort of snakes' cousins. They may also be related to iguanas. This is another genetic dispute that's going on.
Mm-hmm.
Exactly which of those groups snakes are closest to is very much uncertain. It's also uncertain the original reason why snakes lost their legs.
Yes.
So today, when we look at limbless animals, like I said, most of the time you see that they're using their long snaky bodies to burrow through leaf litter or soil and things like that. And indeed, snakes have certain attributes, both morphological and genetic, that seem similar to burrowing animals.
Mm-hmm.
So it's been suggested that the earliest snakes may have been burrowers that then diversified from there,
Yes.
once they had evolved that snake body. But in the fossil record, there are a lot of snake-like lizards that are aquatic,
Mm-hmm.
including the mosasaurs,
Yes.
which were very long-bodied. And there are attributes of snakes and fossil relatives and ancestors that seem to indicate aquatic habitats. So the big debate for decades with snakes has been, did they start off burrowing or did they start off swimming? And which one of these both somewhat supported reasons
Mm-hmm.
was the driver behind the evolution of their original this snake-like form and lifestyle.
Yeah.
We still don't know.
Yes. Once again, the reason we don't know is because it's a very valid question with
Yes.
seemingly good answers on both sides.
Yep. So snake origins are mysterious, which is cool because there are a lot of animals that, we have great indications of their earliest ancestry. Birds, horses,
Yeah.
whales, humans have wonderful transitional fossil records.
Mm-hmm.
Snakes aren't one of them. Snakes are weird.
And those are always for the famous term that gets thrown around and often confused is these are the situations where people talk about the missing links for animals.
Yes.
Is those animals that show a transition between two species or between two states. Now those terms continue to be used even after it has been found.
Well, because you have point A and point B, and the missing link is in the middle, and then when you find it,
There's now
now
two
you
more
have
spaces.
3 points, and you have 2 missing links.
And so that is
Yeah.
once again not an official term
Yes.
that paleontologists use. It is a descriptor that generalizes when a fossil bridges to other fossils or to states of a evolutionary tree.
Right. Technically speaking, because evolution is a continuous process, every species is a transitional
Exactly.
species.
And so it's one of those where it's a very vague, but you will often hear people talk about it. And since we were talking about a subject that it has been used and is a kind of picture perfect example of that situation where you have ancient lizards and then you have ancient snakes, but you don't have a good representation of which lizard
Yeah.
became the snake. And it's one of those things, as you said, we could very well find one of those, and then there'll still be the question of like, all right, but which one? At what point did they first start to lose and which one
Yeah.
first became this snake? And so there's always more.
Yeah. It's just the case of snakes that there's less than many other lineages,
Mm-hmm.
which just, means that there's lots of unanswered questions, which
Yeah.
are the best kind of questions. For other nifty reptiles that we have very little idea of where the heck they came from, someday we should have a colleague of ours help us out and do an episode about turtles.
Yes, absolutely.
Another really weird group.
Yeah, they are arguably one of the weirdest.
So snake origins are bizarre and they're elusive, but there is a pretty decent snake fossil record starting in the Cretaceous. So now I'm going to start working our way through the snake fossil record.
Cool.
Starting in the Cretaceous period. So this is the last period of the Mesozoic, the age of dinosaurs, the age of reptiles. Starting at around 100 million years ago and running to 66 million years ago, the later half or so of the Cretaceous period, we see a bunch of cool snake fossils. Some of these are very strange. They're already diverse, but there's a lot of legs in the Cretaceous snake fossil record.
Interesting.
So starting off with probably the most famous group of Cretaceous snakes, this is a group of snakes that many of them, probably all of them, we don't have the fossils for it, but many of them have hind limbs. And not like the little barely recognizable nubbins that pythons and boas have, but femur, tibia, fibula, wrist bones, foot bones, toe bones.
Weird.
Small but well-developed hind limbs are known in a handful of different snakes that all belong to the same family of Mediterranean region aquatic snakes.
Oh.
This is a family of snakes that were all living in the Tethys Sea, which is a sea that doesn't exist anymore.
Mm-hmm.
Swimming around. They had the anatomy seems to indicate flattened side-to-side bodies,
Yes.
like we see in many aquatic animals.
Yes.
Their vertebrae have some sort of buoyancy adaptations that you also see in a lot of aquatic reptiles.
Oh.
And they're found in these ocean environments. These include famous snakes like Haseophis, Pachyrhacus, Eupodophis. All three of those are known. Their hind limb and pelvic elements are known.
Yes.
And then there are a few others that we don't have the limb region to tell us if they had legs. But they're all thought to be related. Same family. So there's a good chance, they all had legs. They were all adapted to aquatic lifestyles.
Huh.
And these were sort of right there in the middle Cretaceous, 100 million years or so ago, already had taken to the ocean. Now at this point, you may be thinking, all right, well, there you go. Early snakes, aquatic lifestyles,
Yes.
debate solved. Well, let me introduce you to the limbed terrestrial snakes. Especially this one snake from the late Cretaceous that is a snake called Coniophis, which is a very, its skull has a lot of really notable lizard-like characteristics.
Yeah.
So it looks like it's more basal, which is to say closer to the ancestry. And this snake appears to have been a burrower.
Very interesting.
That one's from North and South America, or rather, the whole genus is from North and South America. The specific one at the end of the Cretaceous is, I want to say, North America. Then there are a couple in South America that also were terrestrial living, have some possibly burrowing features.
Mm-hmm.
One of which is also known to have had hind limbs.
Gotcha. Was the other one all four limbs or just?
As far as I know, they're only known to have their hind limbs.
Weird.
So they lost the forelimbs first, and the hind limbs are the only ones that have been found.
Well, the front ones got scraped off first.
Well, as they started burrowing.
Yes.
They scraped them right off.
Yeah.
So hind limbs hung on longer than the forelimbs. And just like in modern snakes, with the little vestiges, we only ever see vestiges of the pelvic region, not the shoulder region.
Which, of course, brings up the question of how were those hind limbs aiding them for the fact that they stuck on a little bit longer?
Yeah, they may have had or rather, maybe they were aiding them, or maybe they weren't getting in the way as much.
Yeah, maybe they were just less of a hindrance, but that's really odd.
Yeah. Now, I should mention an earlier fossil called Tetrapodophis, which has been in the news a bunch in the last few years. Tetrapodophis, and I'll make this one quick, but long-bodied, very snake-like, 4 legs.
Mm-hmm.
Again, small legs, but all 4 of them, from Brazil. When it was first described, it was identified as a very ancient early snake, but then a second group of paleontologists looked at it and identified it as a group of snake-like lizards.
Gotcha.
But not an actual ancestor or close relative of the snakes. That it was a different snake-like group.
Mm-hmm.
So we had 2 studies. One said one thing, one said the other thing, which is not unusual.
Yeah. Especially for a weird group like snakes. But problem with this one is that fossil is in a private collection. Oh, right.
So scientists can't look at it. And this has also been confounded by the fact that it may or may not have illegally been taken out of Brazil when it was found.
Mm-hmm.
So there's a good chance that's all we're ever going to know about Tetrapodophis. So until it reappears from its private collection somewhere, we don't know if that's a true snake ancestor or not.
Yeah, that has happened multiple times in the
Yeah,
history of paleontology where there's been fairly dramatic events with pretty important fossils.
yeah. And they get tied up in legalities or disputes.
Yeah,
It can happen. But in the
absolutely.
meantime, we keep looking. Um, so, in the Cretaceous, you've got your early aquatic snakes, you've got your early burrowing or terrestrial snakes that are just, crawling around on land. But there's more diversity already, right? By the late Cretaceous, you also had freshwater snakes. You also had some very early relatives of modern groups.
All right.
And then there's this one other group is really one that I always like to bring up. These are the Madsoids. So if you look at today, there are two groups of snakes that typically make the top size charts.
Mm-hmm.
Thick-bodied, heavy, long snakes. You have the boas and you have the pythons.
Mm-hmm.
They're different from each other, exactly how, some people put them in separate families, some of them are part of the same family, but they're separate groups.
Mm-hmm.
Well, starting in the Cretaceous, there was another group of snakes that were also thick-bodied, very large.
Yeah.
The Madsoids, also some of them are known with those little hindlimb vestiges as well.
That's cool.
Yep. One species from Madagascar at the very end of the Cretaceous is thought to have grown to just about 8 meters, so around 25 feet long.
Yeah.
Which means that by the late Cretaceous, we also already had giant snakes,
Mm-hmm.
which is cool.
Which is really cool, because for the big snakes that are around today are often one of the apex predators of their environment. It's not just that they're a big snake;
Yep.
they are one of the dominant animals that basically once they're full size, every other animal leaves alone.
Yes.
And so it's cool that there was snakes reaching that big predator size back during the time of the dinosaurs.
Yep. One member of this group, so Madsoia, that one species was huge. There was another species found in India called Sanaja, also from the very latest Cretaceous. This one was smaller, maybe 10 feet long or so.
All right.
This one is one of my favorite snake fossils of all time because Sanaja was discovered. Basically, it had become buried in a depression in the ground
Mm-hmm.
and fossilized there. In that depression, it was also joined by a bunch of dinosaur eggs. So this snake died and was fossilized in a dinosaur nest, and very shortly in front of its face was the fossilized remains of a newborn hatchling baby sauropod dinosaur. So this snake was a species that frequented dinosaur nests,
That's cool.
and the study that looked at it didn't see any egg-eating adaptations in it, so it was possibly, going after baby dinosaurs.
Yeah, it was waiting for newly hatched.
Yes.
And that's cool and could be mentioned just really quick. The snakes that eat eggs today, that is not just a thing that any random snake grabs
Yeah.
that can just grab eggs, because they actually have specialized features on their ribs and bones to crack the egg after it gets inside.
Yeah.
And so there is actually specialization for that. It's not just one of those, there's an egg, I'll take an egg sort of thing.
Yeah. I don't know anything about the fossil record of egg-eating snakes.
Ooh, that'd be a fun one to
That
look
would
up.
be a fun one to look into. So by the Cretaceous, we already have this diversity of oceanic snakes with legs, terrestrial snakes with legs, giant boa or python-like forms, and at least some of them were probably eating dinosaurs.
Anytime another animal eats dinosaurs than dinosaurs is pretty interesting, exciting.
Yes, and the crocodilians did it last episode too.
Absolutely.
Yep.
That's just every animal we talk about. We should find the one
Did
ancestor.
it eat a dinosaur?
Did it eat a dinosaur? Oh, we don't care. We're moving on.
Now, technically speaking, both crocodilians and snakes continue to eat dinosaurs today.
Yes, they do.
There are snakes that eat birds. In fact, there are snakes, this is a little bit of a tangent, there are snakes in caves in Asia and or South America that hang out on the walls and snatch bats out of the air.
Yeah, they do.
Which is super cool to see.
It's really, really interesting.
Yeah. So it's interesting because as diverse as they are today, they had already started achieving a good level of diversity of these ancient, slightly weird forms back in the Cretaceous period. Then the mass extinction happened.
Yes.
End of the Mesozoic, asteroid, plus maybe some volcanic activity, basically took out a large chunk of Earth ecosystems.
Yeah.
Famously took out the dinosaurs, but lizards and snakes suffered as well.
Yeah, people often forget the fact that even though we talk about that time as the death of dinosaurs, mass extinctions affect everyone.
Yes.
You know, it's not like it's just the dinosaurs died and all the other animals were looking around going, "Oh, what's wrong with those guys?"
Yeah. What happened to them?
Everyone took a hit. Some groups just harder than others.
Yeah. And snakes and lizards took a pretty hard hit depending on where you were. Certain groups did not show up again, like those ancient legged snakes aren't known from beyond the Cretaceous period. I don't think most of them aren't even known from the later Cretaceous, but they certainly didn't make it past the mass extinction. Yeah. But obviously some snakes survived. After the Cretaceous was the age of mammals. So the next 65 million years, the Cenozoic era, this was a time where snakes actually have been more diverse during the age of mammals than they were during the age of reptiles.
Yeah.
And the first thing that I want to highlight in the Cenozoic era, following the mass extinction, is that the next 30 or 40 million years is when we see a handful of different groups of snakes submit their candidates for the largest snake of all time competition.
Yeah. That's something to be mentioned right after the death of the dinosaurs, who were by far the dominant, largest, most, biggest predators, biggest herbivores, and one of the most diverse. When they went out, lots of animals, and once again, we're talking about it as if there's forming committees, but lots of animals scrambled to fill the place.
Right.
Of those big predators.
There was a niche open.
Exactly.
That evolution could now go into.
And mammals were still too small to really take advantage yet. Eventually, of course, they did when we get the big predators of the large cats and bears and others, but the crocs did it. They got some really big, massive ones that showed up right after.
Yeah. Birds did it. And other reptiles did it as well. Yeah. So now snakes were part of that, but I'm going to count up a handful of different snakes that have competed for this title. There was a group of snakes that actually started in the Cretaceous and then diversified throughout the first half of the age of mammals, the Cenozoic, that are called the Paleophids. These are known from various places around the world. These were the new sea snakes.
Gotcha.
So the old legged sea snakes are gone. This is an ancient group of snakes. They're not quite like the sea snakes today, but they had very similar specializations. One of them, which lived around 50 million years ago or so that's, mammals are already starting to pick up by that point. We see the start of most of the familiar groups. This was a snake called Paleophis colosseus from West Africa, which is estimated. Now, I say estimated because we usually don't get the full skeleton.
Yeah, it's a lot of little bones.
So we're extrapolating by comparing with other snakes we know, from what sometimes is a little bit, other times is a good bit of the skeleton. This species is estimated to have been around 9 meters long, which, for our American listeners, is about 30 feet. This was a 30-foot sea snake.
That's literally a sea serpent.
Yes. Yes, it is.
That is impressive.
Yeah. The python group actually had another snake about this size. which didn't show up until way, way later, about 5 million years ago or so.
Oh, cool.
That in northern Australia, which was also about 30 feet long.
Right, right. Australia had lots of big reptiles up until recently.
Yes, it did. So we had a couple of 9 meters. Then, the next one up the rung is part of the Madsoids. So the Madsoid snakes, the big, beefy guys from the Cretaceous that I mentioned, have continued on, and they actually last through most of the Cenozoic.
Good for them.
The largest of the Madsoids, and this is a snake that once held the title of largest snake ever known, was called Gigantophis from North Africa, even later than the last one I mentioned, around 30 to 40 million years ago, which is estimated to have been up near 11 meters long, so about 35 feet.
Nice.
Another one that would have been a giant, thick-bodied apex predator in its environment. So the Madsoids, the pythons, and the paleophid sea snakes each had their own sort of attempt at a giant snake form.
Yes.
The winner of the competition came from the boas. And this is one of those interesting cases where the winner didn't win by like a little bit.
Yeah. No.
But completely blows everybody else out of the water.
It really does.
Titanoboa lived earlier than all those other snakes that I mentioned, around that time period that Will was talking about, with where the dinosaurs and the giant reptiles of the Mesozoic were gone, but the mammals hadn't quite risen to dominance yet. We're around 60 million years ago, less than 10 million years after the big extinction.
Mm-hmm.
In Colombia, there is a snake called Titanoboa. Now, Titanoboa is actually known from many, many different bones, representing many different individuals, mostly vertebrae, but also skull bones.
Which is very rare.
Which is very rare. Snakes are made up almost entirely, as far as bones go, of vertebrae and ribs.
Yes.
There's mostly no legs. There's no hip bones. There's no shoulder, scapula, anything like that. So vertebrae are usually what you're going off of in the snake fossil record. Skulls are rare, but very useful. Titanoboa is estimated to have been around 14 meters long. So up in the range of 45 feet.
Yeah.
Which is a stupid size for a snake.
Yeah, it's crazy. And you brought up anaconda earlier.
Yes, I did.
In the episode. And this is one of those beautiful moments where Hollywood was like, you know what? The scariest thing I can think of is a 30-foot snake.
Yes.
and the fossil record was like, 30-foot snake.
I mean, come on now.
No. Come on down to Colombia.
And it's funny, actually, because Titanoboa appears to have been living much like an anaconda, which is also a member of the boa family.
Yes.
Living in freshwater, eating freshwater prey. Titanoboa, what did I want to say about it? I had a thing I was going to say about it. Oh, it also would have been very thick-bodied.
Yes.
So at that size, it also would have been very wide around. It got about a foot or two, at least, in diameter across its body.
Yeah, the way I always remember it, and it was early on, so they may have adjusted the exact... But in the original documentary, for the people who were discovering it and first describing it when they got their first size estimations, were describing that it could very well, at the thickest portion of its body, have trouble getting through normal doors.
Interesting. I wonder if that's the case.
I don't know if that's still there, but this was a very thick, large snake. It was a hefty thing.
I was doing a presentation for a science camp at the center I used to work at, and we were talking about snakes, and I happened to have a tape measure with me.
Yes.
So I did a demonstration where I had one kid hold, one end of the tape measure, and I pulled it out to show them the length of the longest snakes today. And we were in this big classroom in this building, so I pulled it out to 20-something feet, and I was like, look, this is how big snakes get. And then when I tried to do Titanoboa, it turned out the building we were in was not big enough to fit Titanoboa within its walls. So I couldn't do it.
It's fantastic.
Yeah, it's great. And I think that is pretty much the perfect demonstration of how big it is.
Yeah, it is. It's one of those animals that it's hard to really, and this is a legitimate thing when you get to the truly huge individuals of a group of animals, is it's one of, this could change very well how it's living, how it's hunting, how it's feeding, how it's moving around, because you're now getting into different physics when you are almost 50 feet long.
Yeah.
And that's, so it's, this animal could be living in a unique way just because of how big it is.
Yeah.
It's really crazy.
There was I don't remember what it did in the documentary, but the Smithsonian had a reconstruction of Titanoboa put up.
Yes.
That was eating a small crocodilian.
Mm-hmm.
But study of the skull bones indicates that it had adaptations for eating fish.
Which makes sense.
Yeah, so it probably was eating big fish as opposed to... Now, granted, that is to say that if a small crocodilian crawled in front of Titanoboa, I can't imagine why Titanoboa would not eat it.
Yeah.
But it may have been more of a preferential fish hunter.
Well, and it's the same thing with big monarch boas, is if you look up large boa feeding, you'll often get a picture of them eating a deer or eating a caiman or some...
Yes.
But that is not saying that is what they're always... They don't wait until they can only catch deer.
Yeah, or even usually.
Yeah, they are going to mostly be eating rats, fish, larger rats and fish than other snakes.
Mm-hmm.
But that'll be the bulk. Same with even big things like crocodiles. The bulk of a crocodile's diet is fish. The bulk of most predators' diet are small animals, rabbits, mice, squirrels. And then when they get the chance, they take something big. So we always represent the big fossil animals taking down a T-Rex or a crocodile, but realistically they were likely eating the more common animals in the environment.
You go what you can find with what you can find and with what you can catch, and with what's safe.
Mm-hmm.
If I were a snake, I would much rather go after a fish than a crocodilian.
Yeah, absolutely.
Depending on the fish, I guess.
That being said, anacondas have been known to regularly eat young and the smaller species of caiman.
Yes.
Because
as the natural order of nature would dictate how we demonstrate superiority.
Now, once again, that being said, all crocodilians eat any snake they can find anywhere in the world. The other 90% of the time.
Let's agree to disagree.
Well, we need to move on from this point of conversation for time.
I've stopped listening. I don't care anymore. I said my piece. One other thing to note about Titanoboa, just really quick, is that there was even some effort to examine, given its body size, the connection between its body size and climate at the time.
Yes.
So this was a time period where global temperatures were known to be very high compared to today, and the scientists who originally described it even looked to see if they could use its giant size to predict temperatures at the time that would have been required to allow an ectothermic animal to power a giant body like that.
Yeah.
That calculation has been heavily questioned.
Yes.
So it's certainly not a definite thing that you can do that, but it's really interesting to, being big isn't just cool because it looks neat. There may be other things we can learn from giant animals.
Absolutely, because that's been a debate with other, in the past, dinosaurs and other large reptiles on how hot does it need to be active, but also at what point are you so thick that heating you up would begin to cook parts of you.
Yes.
And so you get into the weird thermodynamic physics when you're dealing with an animal that's bigger than any we have reference for that it's related to.
Yes.
And so you get into really weird, unique questions when you deal with these kinds of things.
Yeah. That's another episode to do.
Oh, absolutely.
Temperature. I'm going to go ahead and air quotes cold-bloodedness and warm-bloodedness.
Yes.
End quotes. One other thing. So back on we got off on a Titanoboa tangent, which is bound to happen.
How can you not?
How can you not? So the Cenozoic, lots of giant snakes. There were also, just a huge diversity of snakes already in this time. I don't have other specific taxa to pinpoint. But I do want to point out that around the middle of the Cenozoic era, around the transition from the Paleogene period to the Neogene period, was perhaps the biggest event in snake evolutionary history since their inception. And this was a major turnover where we saw ancient groups of snakes, or rather the older dominant groups of snakes, give way to the more modern groups of snakes.
Interesting.
So in the early part of the Cenozoic, you know, boas and pythons and those ancient sea snakes were very common. North America and Europe were home to boas and snakes like that. But then this transition happened, and you started to see the rise and diversification of the colubrids, so the snakes today that include, like we said before, garter snakes, rat snakes, milk snakes.
Yeah.
You also saw the rise and diversification of the major venomous snake groups, like the vipers, like the cobras, including the modern day sea snakes, which seem to have kind of taken over at this time for those ancient sea snakes waned. So that basically the third
Which is
edition of sea snakes.
cool in and of itself that multiple times snakes have gone back to the sea.
Yep, there have been different regimes of sea snake dominance. So this big shift happened from old snakes to more modern style snake faunas. And what's cool is that the transition happens around the same time that another major branch of life also experienced a big diversification, and that was grass.
Right.
Grass has been around for a long time, but grasslands have not.
Mm-hmm.
Prairies and savannas and whole biomes built around grass. Dinosaurs didn't have that.
Yeah.
You know, Titanoboa didn't have that. That kind of took off in that middle part of the Cenozoic era, the middle part of the Age of Mammals. Lots of mammals enjoyed new niches after that. Lots of sort of plains, running, grazing mammals. Also, rodents did really well
Yeah.
around this transition. And very likely because of how well small animals were doing, this may very well have been one of the big drivers of the snake turnover.
Yeah.
Was that now this new ecosystem regime had started and snakes shifted over to adjust for it.
Yeah. Started providing a whole new wide selection of food.
Yes. So we see a lot of modern day snakes that are adept at living in those kind of ecosystems. Hunting is, some snakes today are very specific small mammal hunters. So after this big shift, you would start to see snake faunas that looked a lot more like today. You know, the boas and such were pushed out of North America, and you had things more like today. That basically brings us to the present. There is one more snake I want to mention, and this is in Australia at the very end of the Ice Age. So last time we had a news piece where we talked about the Australian megafauna.
Yes.
And how at the end of the Ice Age there were lots of giant species all over the world, including Australia. Well, one of the Australian megafauna species was a madsoid snake named Wonambi. And Wonambi was green anaconda sized, up to maybe 6 meters, 20 feet or so.
Yeah.
This was a giant snake, part of the Australian Ice Age megafauna, that was a madsoid, part of that same family group as that dinosaur-eating snake back in the Cretaceous. It's the last one that we know of. And this really always blows my mind, because you always think about snake, you think about groups of animals, and some of them are really widespread today and have been that way for a long time. Some of them are just remnants today of what used to be a vaster, more diverse group. The madsoids held on from the late Cretaceous 100 million years right up to the end of the Ice Age. Recent enough that they may have interacted with humans, this Wonambi snake, and disappeared within the last several thousand years. We just missed this group of snakes.
It's crazy how varied the lifespans or the existence of different groups of animals can be. Because you have some like typically when we think about certain groups of animals, you can see them come, and then you can kind of see them all go. But
Yeah.
every now and then you get these ones that will narrow and then hang on
Yep.
and just refuse to go extinct. And there's even some animals around still today where there's like 2 individuals, or there's just a couple species of this group that is still hanging on.
Incidentally, the tuatara
Is a great
which
example of that.
not a lizard, but a very close relative of lizards, the rhynchocephalians, which were super diverse, super widespread, especially in the Mesozoic, the age of reptiles. Today, there are 2 species.
And they're just found on a series of islands.
They live in North New Zealand and South New Zealand.
Yep.
They might even be the same species, depending on whose genetic work you look at. And that's it. That's all that's left.
Yeah.
I imagine that the Madsoid snakes did that, and we just missed them.
Yep. Just.
So that's snake evolution in a super condensed nutshell.
Yeah. As with just any animal, but especially with reptiles, because reptiles experienced during the Mesozoic crazy diversity, and is also why so many of them are hard to nail down in their family tree. But there's always so much when it comes to their groupings.
Yeah, and they go back a long time. And they go back diverse. Snakes have been diverse and successful since the Jurassic.
Mm-hmm.
So 150 million years they've been doing pretty well.
Yeah.
And it's interesting that they seem to be doing about their best today. That they keep getting better.
It's always cool because, and we can focus on this topic another time, but because you constantly get the question of why were things always bigger is the most common, but also, why are all the cool ones extinct, or why? And it's, the real answer is, well, because you're used to what's around now.
Yeah.
But there are groups that are doing as well or better than they have ever been doing.
Yep.
And it's
absolutely.
It's always really great when you come across a group like that, because to know that you didn't miss the heyday, you're actually getting to see it.
Yes. Especially today, because so many animals' heydays, if they were having it, ended during the Ice Age.
Yes.
Before we wrap up our snake talk, one other thing, just like Will did last episode by talking about some research that he's done, I want to just very briefly hit upon some research that I've done. Much of my research on snakes has been very simple faunal identification. So you had a fossil site with a bunch of different species living in it. What were they? I did that in the site in Gray, Tennessee, and as well as one in South Dakota and one in China. The Tennessee site was interesting because this was Miocene, right? Late Miocene, 5 million years ago or so. And what we were interested to look at, and I won't say too much because this will be published sometime. What we were interested to see, in part, was the makeup of the fauna. We had mostly colubrids and vipers, which are very modern groups of snakes, but we also saw some vertebrae that looked like boids. So this may have been right at the tail end of that turnover. There may have still been some of these holdovers in North American environments that still had snakes like boas hanging on in places that they have since largely vacated.
Yes.
The South Dakota site was an Ice Age site. Where we're looking for something very similar. Snake species don't seem to have gone extinct very much during the Ice Age, but they did move around a bunch. Oh. So during the Ice Age, and in a lot of different groups of animals, what you had was types of organisms living together that you don't see today.
Yes.
So you may have had a type of snake and a type of mammal overlapping in a way that doesn't exist anymore, as their ecosystems changed and they moved from place to place. This is something that my undergraduate professor was really big on, non-analog faunas. An extreme example of this would be in the Cretaceous, there were forests at the poles.
Yes.
Because there weren't permanent polar ice caps. So there were fully functioning, diverse, temperate, forests kind of more like what you would see in the northern part of North America, but up where they got, 6 months of darkness. and 6 months of sunlight in ecosystems, and we don't know how they worked because we don't have anything like that today.
Yeah, completely different than our modern examples.
Yeah. So snake communities have shifted through time. So looking at the faunas, the makeup of different ecosystems in the past can tell you some interesting things about how the different groups of snakes have varied over time and their ecosystem roles. Another study that I did, and this was a more minor study that I presented at a conference, was looking at snake vertebrae and trying to basically look at how the shape of vertebrae can reflect where on the body it is.
Right. I remember that poster.
Yeah. So this is something that I didn't really mention earlier. But when you're looking at snake fossils, like we said before, vertebrae are almost always what you're going with.
Mm-hmm.
Skulls are rare and ribs are useless.
Yeah.
So vertebrae are what you have to use for identification most of the time. And it works to a point, but not only do vertebrae look different between different snakes, vertebrae look different depending on where on the snake you are.
Mm-hmm.
And you can tell neck from trunk from tail, but early body versus middle body versus towards the tail can be really difficult to determine if you don't know much about your particular snakes.
Yes.
So I did a study where we statistically determined the shape of snake vertebrae and analyzed how they changed along the column of, I used a few different groups of snakes. This is really beneficial if you can tell what part of the body your snake vertebrae came from, because a snake can have 1, 2, 300 vertebrae in it, and you usually don't get most of them. So that was a nifty study as well.
Yeah, and that's once again one of those studies that is, as at their core all studies are, but is mainly a tool for future studies to be able to compare to what you found if they find a random snake fossil or vertebrae.
Yeah, they're reference studies.
Exactly.
Building a reference of information that is then sort of, this is what we're drawing on for future research.
And those studies get overlooked a lot of times just in general science,
Yeah.
because you're not ending it by saying, and therefore I can now tell you this about snakes. It's just you are building up a body of data that we didn't have before, or looking at it in a new way we hadn't before, so that everyone else doesn't have to do it every time they do a snake study.
Yes.
So that we can do it on this group of snakes, and now that is a tool already pre-made for another study.
Yep. And that, those are the kind of studies we do when we do our news section or when you see them online. But if you're doing research, that's what you're reading.
Oh yeah, those are
a lot of, all right, these 4 different scientists studied this site and they all found these different groupings that they identified of the species that lived here. What were they? Here's what they found, here's what they found, and we put that together into a big picture of what this ecosystem looked like.
The big reference studies are by far the core of what you are using, because it is pure information.
Yes.
It's just
data.
Pure data. And therefore you can translate it directly to what you are using in your study.
Yeah.
Cool.
Yeah, so snakes.
Snakes, still a pretty good group of animals.
So now that you've listened to this, we'll go ahead and we'll see. The viewers can vote and decide which group of animals is the best. They're cool. It's cool actually to compare crocodilians and snakes because their histories are so contrasting. That where crocodilians sort of had their peak diversity in the past and are now minor remnants, snakes are extremely diverse today.
Yes.
We said last time crocodilians have 25 species at best.
Yeah.
And snakes have 3,500 species.
It's ridiculous.
It's very different. The groups themselves have hit very different points in their history.
And it's really one of those things that stands out, because then also, snakes have been very diverse as far as snake designs go. But as we mentioned earlier on, they're all long, thin bodies, predatory, and slithering, swimming, or burrowing, with a couple of other, but using that long body for locomotion.
Yeah.
while the crocodilians had crazy diversity. You could compare two different crocodilians and crocodilomorphs next to each other, and you would be hard pressed to, at glance, say, "Oh yeah, those things are related."
Yes, their body shapes were dramatically different. Their lifestyles and their diets.
Becoming basically different animal, different ecological roles. You had ones that were very likely serving as prey for others.
Yeah. You could, in theory, have an ecosystem that was made up largely by crocodilians.
Exactly, that were eating the plants, eating the plant eaters.
Yeah. In the water, on the land, in the trees. Snakes can't do that.
Yeah, and so snakes have and that's one of the things that always stands out to me about snakes, is that they are a super specialized group, and yet have persisted.
Yeah.
Because typically when you see super specialized, they dip when there's a mass extinction, or they disappear completely.
Right.
Whenever you see, that's what happened with the saber-toothed cats. That's what happened with the dinosaurs that had become highly specialized because they've been around so long. When you are really, really good at one way of life, if that way of life changes at all, typically you're SOL. You're just gone.
Yup.
Snakes haven't.
Which is interesting because it seems that snakes evolved a very specialized body plan that is good for a generalized variety of lifestyles.
Which is a really unique scenario.
It's pretty... They're pretty special.
Mm-hmm.
We should do 6 more episodes just about snakes.
This is just, the podcast is getting retitled.
Snakecast.
Snakecast.
Common Descent. On that note...
If people don't vote down this episode just for that one, I'm going to be disappointed with humanity.
I would also be disappointed. So, wrapping up our snake episode, a few things that I do want to announce. I do want to say before we finish up, in addition to just saying thanks for listening and the usual stuff, we have done 3 episodes now.
Yes.
We have basically established our internet places. We are now hosted on Podbean. We have our Twitter and Facebook. We have our blog going. Maybe by the time this episode comes out, or shortly thereafter, we will hopefully be established on iTunes as well.
Absolutely, but it will be coming in the future.
Yep. So if you can't listen to this one on iTunes, perhaps the next one. At this point, I think it's a great opportunity for us to say that we would love to hear from listeners.
Yeah, absolutely.
We talk about a lot of cool stuff. If you have questions you'd like us to answer, we'd love to answer them. If you have suggestions for episode topics you'd like to hear, next episode won't be focusing on a specific group of animals. We'll vary up our topic choices.
Yeah, we're going to be branching out into a more overarching concept of some aspect of evolution.
Yeah. So, we have a whole list of topics that we could do. We could do this forever. But if there's a topic that our listeners want to hear about, we'd love to hear about that. We'd love to follow what people want to hear. So between all the social media and all the hosting sites, there's a million ways to get in touch with us. We also have a Gmail, commondescentpodcast@gmail.com.
Mm-hmm.
So feel free to reach out and contact us if you have questions, comments, anything like that. We'd love to hear it.
Absolutely. Yeah, no, it'd be really great to be able to hear either what you guys think about what we're talking about, questions you have on things we mentioned, or things you'd like to hear more about, or new topics.
Yes. We could talk about what we want to talk about forever.
That's what we do. It's what we've been doing our entire time of knowing each other.
Specialty.
So
it's our superpower.
A change of pace is always welcome.
Yeah. So there you go. One fortnight in the future, we will meet again for the next episode. Until then, I think that's all my announcements.
That's all I've got as well.
Okay. Until then, go snakes.
And more so go crocodiles.
Go snakes.
You guys all know. I trust in you guys. You're all very intelligent people.
Snakes. All right, let's leave.
All right. See you,
Adios,
everybody.
everybody. Join us next time.
Thanks for listening to the Common Descent Podcast. For more from us, you can follow us on the Common Descent Podcast Twitter account, Facebook page, or on our WordPress blog where we post additional cool stuff for each episode. The song you're hearing is called On the Origin of Species by Protodome. You can find this and other video game remix music at ocremix.org. Thanks again for listening. We hope to see you next time.